In this video, I'm going to introduce the concept of NMR, which is an analytical technique. NMR stands for Nuclear Magnetic Resonance. So the first thing we need to say is that certain nuclei with an odd number of nucleons is just the fancy title for the particles in the nucleus, so that's the protons plus the neutrons. So if you've got an odd number of protons and neutrons when added together, these nuclei have a property called spin. So if my whiteboard pen here represents the nucleus of one of these nuclei, the property of spin means it can have a magnetic moment, which basically just means it can act like a tiny little bar magnet. So magnets can either spin in one direction or they can spin in another direction. So they can be north, if you like, or south. If you then compare that to an external magnetic field, so I've drawn an external magnetic field is running in this direction, then the spin, the magnetic moment of the nucleus would rather be aligned with the external magnetic field. So if I use the sort of pen top as the direction, then it would rather align itself in the same direction as the external magnetic field. If you then expose your nuclei to radio waves of the right frequency, what you can get the spin to do is actually flip round into the opposite spin state. So remember, the nucleus prefers to be running in the same direction as the external magnetic field. If you can get the right radio wave frequency, you can flip the spin state around. And what that actually does is it raises its energy level. So if you think of this as an energy axis, so it would rather be in this spin state, but with the right radio frequency, it'll flip round and go up to there. So essentially, these nuclei with odd numbers of nucleons can absorb radio waves. And that's kind of the mechanism that's going on. Now this process of absorbing the energy and increasing the energy level is called resonance. So we can now explain where NMR comes from, or nuclear magnetic resonance comes from. The nuclei, it's all about the nuclei of certain atoms with this odd number of protons and neutrons when added together behave like little magnets, have this magnetic moment or this spin, property of spin. If you apply the correct amount of radio wave energy, then you can get the spin, the magnetic moment, to resonate. So what's it going to work with then if it's to do with nuclei with odd numbers of nucleons? Well, if we think about the hydrogen 1 isotope, what's in the nucleus of a hydrogen 1 isotope? We've got 1 proton and no neutrons. That's an odd number, so it's going to work with the H1 isotope or proton. It will also work with the carbon-13 nucleus, because in the nucleus of a carbon-13 isotope we've got 6 protons. Carbon's got a proton number of 6 and 7 neutrons. 6 add 7 is an odd number, 13, and so it's going to work with these 2 nuclei. These are prevalent in organic compounds, and so therefore NMR is a great analytical tool for organic molecules.